Number 6. A projectile is launched across flat ground at an angle theta to the horizontal and travels in the absence of air resistance. It rises to a maximum height h and lands a horizontal distance r away. What's the ratio h over r? So let's first draw this down. We have ground, and at a certain angle I'm gonna shoot this in the air. So due to the gravity, it's gonna make a parabolic shape, and at one point we're gonna have the highest position in terms of the height, and then we have a horizontal distance that gives us the range. Okay, we have only one projectile, unlike the last problem. And the rule of thumb is you always have to split the projectile motion into two components, x and y. So I'm gonna write down the x component and the y component. Okay, just separate this. For the x component, we're gonna start out with the velocity, initial velocity, x. Oops. Gonna be the initial velocity times the cosine theta. Okay. If you still don't get this, you should still review the trick in your math book. I'm just gonna assume you all know this. So VIY is VI sine theta. Okay, a simple ratio. And then we have the acceleration, but there is no acceleration for the x component, because first, air resistance is ignored, and second, there's no gravity acting on the x direction. However, on the y direction, we have gravity, -10 meters per second squared. What else do we need? The height and the distance. Okay, for the height, I'm gonna set the h because that's our focus here. And for the range, I'm gonna choose 1/2 r. Okay, so let me make it clear that my study right now is at the maximum. Okay, so it's only the first half frame, and I can choose that because this is very symmetric parabola that all you have to do is multiply by 2 when we deal with the full range. Okay, what else do we need? We need time, but time is shared for both x and y. Okay, so I'm gonna write just t there. And final velocity is important in the y component. Why? Because at that height, it's not moving in the y direction. And for the x component, it has a constant velocity throughout the projectile motion, so we can simply ignore that. Let's pull out the right formula for both components. For the x component, because there's no acceleration, we're gonna just have to use x equal vixt, and then for the y equation, y equal, okay, you have to use this kinematic equation. Alright, so for this particular case, I'm gonna plug in the corresponding values. So for our x, it's gonna take the 1/2 r over 2, and for the initial speed or velocity, we have vi cosine theta t, and for our y, it's gonna be h equal vi sine theta t plus 1/2 times -10 and then you have t squared. I'm gonna multiply both sides of the x equation by 2. Okay. Notice that you shouldn't, combine these equations yet. Alright, so 2's cancel out. I have r equal 2 times vi t cosine theta, and then the h, I can spice it up by simplifying it. Okay, that's what I have. So I'm gonna set equation 2 here, equation 1 there. So all I have to do is equation 1 over equation 2, and I eventually get the ratio of h over r. So let's write that down. And when I divide 1 over 2, the equation 1 over 2, I get an expression okay. I can eliminate at least a t on both top and bottom, 1t, or visually it might be more appealing if I separate this into two different fractions. So let me separate the fraction. Oh, what am I doing? Alright, when you take a look, the times can cancel out nicely, except that time is still left, right? So I'm gonna just cross out the exponent, and also notice that the initial velocity can be cancelled out on our first term. So this is equivalent to sine theta over cosine theta times 2. Well, you see the sine theta over cosine theta to be tangent by the definition of tangent. The problem is on the right side. You might go, what am I supposed to do this? Because we don't have time in our choice. We don't have cosine theta. We don't have initial velocity. But somehow we have tangent theta in the left term, on the first term. So we are in the right track, but we just have to do something to our second term. To achieve that, I'm going to use a different kinematic equation that deal with the time, initial velocity, and cosine, or at least indirectly. And that is in the y component direction, we have this formula. When we achieve the maximum height, the VFY is gonna be 0. Initial velocity is gonna be just what we had before, and then the acceleration is gonna be negative 10 meters per second squared, and then we have time. So I can find the time by moving the negative 10t to the left side. I have 10t equal v initial, the initial velocity times the sine theta. However, you have to divide by 10, so that's what you get for the time. So when you plug this in here, when you plug in there, you will see that VI cancel out and the sine theta and cosine theta becomes tangent theta, and we are happy about that. So let me write that. So tangent theta over 2 minus 5 times the initial velocity times sine theta over 2 times 10 and initial velocity and cosine theta. So initial velocity cancel out. The sine theta over cosine theta becomes tangent theta. 5 over 20 becomes 1 over 4. And then I have tangent theta over 2. Common denominator, or at least LCM, can be 4. So this common multiple, yeah. So 4. And when I have 4 here, I have to multiply by 2. So 2 tangent theta minus tangent theta. So ultimately I get tangent theta over 4. Do we have a choice? Or I see E in our question. So the answer is simply E.